Ladies and gentlemen, welcome back for another flipped classroom video with Miss Flanagan. Today we're going to talk about organic chemistry. Organic means that there is carbon in a compound. So if you ever are looking for an organic compound, you're looking for something that contains carbon. Carbon can make 4 covalent bonds. Organic substances also have super low melting points. They have weak covalent bonds holding their atoms together, which makes their their melting points very low. Again, all organic substances have carbon in them. Next, hydrocarbons have hydrogen, hence the hydro part, and carbon in them. These can be found on table Q. When we talk about different homologous series, we're referring to 3 different types: alkanes, alkenes, and alkynes. Alkanes have all single carbon-to-carbon bonds. They're what we call saturated hydrocarbons. Their general formula is CnH2n plus 2, and you can see an example here on table Q. Next, we have alkenes, which have at least one carbon-to-carbon double bond, making it an unsaturated compound with a general formula of CnH2n. And then lastly, we have alkynes, all kinds of different organic compounds. I'm just kidding. Alkynes have at least one carbon-to-carbon triple bond, still an unsaturated compound. The general formula is CnH2n minus 2. Again, all found right here on your handy-dandy table Q. Next, we have isomers. Isomers have the same formula, they just have different structures, meaning their atoms are connected in different ways, and so they have different properties because of this. And lastly, in a multiple covalent bond, more than one pair of electrons are shared between 2 atoms. Keep in mind, there are 2 electrons in each bond. Next, we're going to table R. Table R contains all your most important functional groups. Please remember this. This is so important. First, you have your halides, which include some halogen, group 17 element, and then an assortment of carbons and hydrogens. Then you have alcohols, which have an OH and an ending of OL. Then you have an ether, which is an O somewhere in the middle of an organic compound. Then you have aldehydes, which is a C double bond O, somewhere at the end of a compound. Notice when you only have one of these bonds in the functional group, that means it's at the end. But in ether, it had a bond on each side, so that means it's in the middle of the compound somewhere. Aldehydes end in Al, just like they start with the word Al, aldehyde. Ketones are a C double bond O found somewhere in the middle of a compound, hence the bond on either side of this carbon here. Ketones end in ONE, like pentanone. Organic acids, an electrolyte group. They are a C double bond O and an extra OH. They are found at the end of compounds. And when you're naming these guys, you add IC to the end of the name and then acid. Esters come next. Esters are a C double bond O and then another O on the side, found somewhere in the middle of a compound. They end in O8. And then amines and amides both have nitrogen. They are the only 2 functional groups on this whole table that have nitrogen in them. The difference is amides have a C double bond O in their chemical formula. Also, the more carbons you have in a chain, the higher the boiling point will be, and the less carbons you have, the lower the boiling point will be. So as mass increases, the stronger the forces between those atoms. Next up, we have to talk about the numerous organic reactions that occur in this unit. First is addition. Think back to math. When you add 2 numbers together, you get one answer. So, in our addition reaction, you begin with an unsaturated, an alkene hydrocarbon. And what happens is, in this example, bromine comes in, attacks that C double bond, and it breaks to form one product, a substituted alkane. Substitution, just like you could have a substitute teacher if I was out one day, you have some sort of saturated hydrocarbon, like an alkane. You have Cl2 that comes in, replaces one of those hydrogens to form 2 products. Notice the difference. Addition has 1 product, substitution has 2 products. Next is condensation polymerization. Sometimes they'll refer to this as dehydration polymerization, and it's basically the process of taking two smaller molecules, removing water from them to form a larger one, hence the dehydration part. When you're dehydrated, your body is losing water. Next up is fermentation. This process breaks down glucose or sugar to produce alcohol, typically ethanol, and carbon dioxide. That's an important one to remember. Next is saponification, which makes soap. Think the first four letters in the word saponification kind of look like the word soap. Oh, good way to remember it. Esterification, notice the word ester in esterification. Esterification makes an ester. Ah, what a coincidence. To make an ester, you need an acid, especially an organic acid like I have here, plus an alcohol. And those, when you react them together, will form an ester and water. Voila! Next is combustion. That's what happens in your fire. It's when you react some sort of hydrocarbon with oxygen to produce carbon dioxide and water. And lastly is addition polymerization, which is when you add two smaller molecules together to make one large, long polymer. That's all on organic. See you next time, folks.